Hola, buenos días, buenas tardes ya, por la hora que es. Aquí estamos en el simposium. Ahora, estamos en el simposium, el ciclo de conferencia de los institutos marinos del Consejo Superior de Investigaciones Científicas. Y en el día de hoy nos acompaña Diego Macías, desde el Instituto de Ciencias Marinas de Andalucía, aquí en Puerto Real, y pues voy a hacer una breve descripción. Bueno, primero agradecer a Diego su participación en este ciclo y os voy a dar una breve reseña. Bienvenido a todos los usuarios. Hemos tenido que cambiar por unos problemas técnicos a última hora del link en el canal de YouTube, pero estoy seguro que os estaréis conectando. Entonces, como decía, Diego Macías es compañero y amigo aquí del instituto, estudió Ciencia del Mar en la Universidad de Cádiz y se ha incorporado recientemente como científico titular tras trabajar más de 7 años en el JRC, el GRC, el Centro de Investigación Común de la Unión Europea en el norte de Italia, donde ha desarrollado el Marine Modeling Framework de la Comisión Europea. Este framework, este Marine Modeling Framework, es el Digital Twin que emplea para evaluar el impacto de las distintas opciones de gestión sobre el estado ambiental de las aguas europeas y constituye un elemento clave para la evaluación de las medidas dentro de la directiva marco de estrategias marinas. Diego Macías ha publicado más de 80 artículos en su carrera de investigación en revistas internacionales y es coautor de más de 20 informes científico-técnicos del GRC sobre la aplicación de estos modelos de los Digital Twins en la aplicación a la gestión. Entonces le dejamos la palabra a Diego, dará una presentación alrededor de 40 o 50 minutos y posteriormente habrá un turno de preguntas que yo actuaré de moderador y lo mejor es que la vais escribiendo en el chat del YouTube, del canal YouTube del instituto, y entonces al final pues las iré leyendo y se las iré preguntando a Diego y él gustosamente las irá respondiendo en directo, ¿vale? Si es que pues nada, de nuevo agradecerte, Diego, tu tiempo y seguro que es súper interesante la charla.
Muy bien, gracias Gaby por la introducción. La charla la voy a dar en inglés, en caso de que tengamos algún escuchante extranjero. Voy a compartir la pantalla, espero que se vea bien. So, as Gaby was mentioning, I would like to share with you today my experience as a policy officer at the Joint Research Center of the European Commission. And in particular, I would like to explain a bit how knowledge, how science is used at European level to implement and to assess different policy options. So the first part of this talk will be a bit on the nature, structure, and how the European Union works. I know that this is a bit unusual probably for the audience today, but that's something that it is not really clear because of the organization of the European Union. But I think it's quite useful to know how things work at European level and how the work that we are doing in our research institution, in our daily work, is useful and is used actually in order to make a decision at European level. So when one thinks about Europe, the first thing that comes to our mind is that this is a very complicated confederation of different countries with a very complex structure. The reason of this very complex structure is that the European Union was not created from scratch to the actual state of the Union, but is rather the consequence of a series of treaties or agreement between different countries with the diverse objectives, which have been evolving with time. It's just exemplified here until everything crystallized to the European Union as we know it today. Because of these complex origins and because of the many different stakeholders that are involved in creating this confederation of nations, the structure of the Union, it's complicated. So we have here the different European institutions, which are the main bodies, governing bodies of the EU. You might be familiar, or you will be familiar with some of them, like the European Commission or the European Parliament. But at the same level of importance, we can find some other structures and bodies like the European Court of Auditor, the Central Bank, or the Court of Justice. So it is fairly complicated, but I would like to, I'm not going to give you a talk about the structure and function of the European Union, but rather to go to the details on how European policies are made, how are they evaluated, and what is the role that the science, and in particular marine science, plays in all this process. So in order, the normal functioning of the European Union when it comes to create a law, a legislation, it's called the ordinary legislative procedure, which is a series of steps. So always start with the Commission. The Commission is the technical body of the European Union. It's made up with experts in many fields. It can go from law to environmental sciences to human sciences. So the Commission makes a proposal. It can be because the Commission has are willing to do something, or because some member states has asked the Commission to make a proposal on some particular issue, or because the society is asking for action in some aspects. So this proposal is then sent to the Parliament, who make a position or an opinion. Then this is sent to the Council. The Council also can approve it or propose several corrections, which is then sent back to the Parliament, who can reject or accept the correction, and everything is sent back to the Commission. So the Commission evaluates the proposal, and with the assessment of the experts, make amendment changes, or it rejects the changes that has been proposed by the political bodies, and then everything is sent back to the Council. So the Commission is the central player in any implementation of any policy, and as I was already mentioning, the staff of the Commission are mostly experts. So they are functionaries, they are civil servants who are expert in many fields, which are the fields of competence of the Commission. This is already a complicated thing to do. So it has many steps. It has to come from backward and forward. But this is not the end of the story. So once an European legislation is approved, it goes to a continuous process of evaluation and improvement, which is called the better regulation. So this better regulation is a cyclic evaluation, which normally takes between 8 and 10 years to complete, and it has two key processes. So one is the evaluation. So they need to evaluate what has been the impact of the implementation of that particular legislation. So what has changed since the legislation was applied? And then they have also the impact assessment. So these are future projections. So what will be the impact of the full implementation of the policy? What will be the consequences of, for example, stopping this policy altogether, or using different options? So do we need to improve it? Do we need to make it more relaxed, etc., etc.? So looking into the future. This is, as I already mentioned, this is a process that is applied to all European legislation and is done again by the Commission, so the technical body. This can be done by their own scientists, which work for the Commission, or it can be done with external help. So scientists or experts from member states, or even hiring consultancies. This evaluation again is knowledge-based. So in our field, in the environmental field, it will be always based on science, so in scientific knowledge. And in this process, the JRC, the Joint Research Center, plays a key role. So JRC, for those who don't know, it's a Director General of the European Commission. So it's an integral part of the Commission, but it is mainly composed by scientists. So people working there, the staff of the JRC are 90% scientists, expert in many different fields, all the fields in which the Commission has a responsibility. I will come a bit later about the JRC. So This process, this better regulation already mentioned, is applied to all European regulations, and for us as environmental scientists, that imbricates very well with the Green Deal. So the European Green Deal, you are all familiar with that, is this objective of the latest Commission to make Europe greener, to make Europe more climate resilient, to reduce our impact on the ecosystem, and to reduce our dependence on fossil fuel. So all the European legislation existing before the Green Deal and the new ones are targeting towards helping achieve the objectives set by the European Green Deal. In our field, let's move up narrow our field to the marine sciences. This has implication for many legislations, such, for example, the Zero Pollution Initiative, that it deals with the pollution, the littering, etc., of marine and fresh waters. Also, the Circular Economy Action Plan, again, Single-Use Plastic Directive, etc. And in particular, for the marine environment, the 3 European legislation, which are most important for the marine environment, which are the Marine Strategy Framework Directive, the Common Agriculture Policy, and the EU Biodiversity Strategy. So all these policies, all these actions need to be evaluated, need to be improved, always based on knowledge. So this is what the JRC is doing in the Commission. So JRC is the Science and Knowledge Service of the Commission, and its mission is to support EU policies with independent evidence. So it has not a political agenda, it is totally objective, and is based on knowledge. So the main aim of the JRC is to produce knowledge, which is first class scientifically, but also fully policy relevant. Also, it manages knowledge created by others, so by me, by you, and they try to make sense of this, all of this information to try to inform the policy making. These are the fields which are tackled by JRC scientists. You can see there are many of them. Of course, they have to be covering all the fields, all the aspects for which the European Commission has competence. In our case, the environmental sciences and earth and planetary sciences aspect are probably the most relevant. And at JRC, this type of research is mostly done in Directorate D, which is the Sustainable Resources Directorate. And in particular for the marine environment, it's dealt with by the Unit D2, which is the Water and Marine Resources Unit. There you can find different groups working from aspects related with the fisheries, so the Common Agricultural Policy. There is also expert in the biodiversity, invasive species, environmental status indicator like the ones that are contemplated in the Marine Strategy Framework Directive, etc. But everything is concentrated in this Unit D2. So if we just go now to the marine aspect of the work at JRC, again, this is an example, a graphical example of the work the JRC is doing. So JRC is taking knowledge that is created, again, by their own scientists or by anybody in the world, and try to streamline all this information in order to make it useful for the policy making. The way they are doing that is mostly by implementing and applying numerical models, now what is called the digital twins. So they use these models to try to extract the useful information from the knowledge to inform the policy making. And I would like to move now to the second part of this presentation, which is going to be about one of the models that the JRC has created, which is the Marine Modeling Framework, which is a multidisciplinary model that it's aiming to represent the functioning and the dynamic of marine basins. So it's a regional air system model, which is composed by different elements. So at the center of this modeling framework, we find hydrodynamic biochemical model. So it represents how the water moves, how the primary production takes place in the ocean, and how that evolves with time. It also has a hydrotrophic level included in the model, so it has a full wet model within. It contemplates, for example, the direct impact of anthropogenic actions such as fisheries. Of course, it also integrates the atmosphere-ocean interaction, so climate change impact can also be assessed and evaluated through this system. And finally, it's connected to input from lab. So it can be energy or chemical substances, fresh water, etc. So it's a complete model that allows to represent the dynamic of a marine ecosystem. These models are used for scientific research. So these are very valid scientific tools, and always with the aim of informing policy. So the type of research that JRC is doing with this model is not, let's say, as free as we can do in a purely research institution, but it's targeted for a policy need. This is another representation of the different elements of this modeling framework. So more schematic. So you have the coupled hydrodynamic biochemical models receiving inputs and forcing from the atmosphere, from the rivers, and then all this data is used to feed full web models. I also wanted to point out that the structure and the way of coupling of these different elements is not decided only by JRC, but it's decided jointly with the scientific community at large. They do that with a dedicated advisory group, which is the MEMO group. They meet almost every year to decide what is the best way of applying model, which are the best model to be applied, how to implement those models to answer the policy question. So in this way, JRC is making sure that the models that they are using are up to the latest standards of the scientific research. And at the same time, that will probably help to the rest of the scientific community and to the member state to accept the analysis and the work that is done by the MMF. So already mentioned that the MMF is a research tool, and as a result of the work of the last few years, there has been published at least 25 peer-reviewed articles in international journals, and it has been used for at least 22 technical reports for policy support. The reason of doing that is that the support to the policy, it has to be science-based or evidence-based, but it has to be based on science which has been peer-reviewed. We are all scientists. We already know very well the issue of the need of getting our publication peer review, and it has been very clear shown to the general public with all the papers or the article that has been published about the COVID crisis that we have had the last months, in which peer review or article has been put out in the open. Afterwards, they were not really back up by after the peer review science. So that's an important part of the work of JRC. So they wanted to make sure that the tools that they are applying are up to the best possible standard, scientifically speaking. But then the final aim of this work is to do a policy support. And these models are really useful in the context, for example, of a holistic policy such as the Marine Strategy Framework Directive, because they can't allow to take into the multidimensional aspect of the natural system. So incorporating environmental, social, economic issues all together on the same tool. That's why This is one of the major tools that it's involved in the MSFD evaluation cycle, which is the new cycle is due by 2023. And this is one of the tools that are going to be used in order to make the impact assessment. So how to make this MSFD better into the future. The marine modeling framework has been implemented to the different European regional seas. So for the Mediterranean Sea, the model is fully implemented and developed. So we have the hydrodynamic, the biochemical, and the food wet components already working. While for the Black Sea, North Sea, and the Baltic Sea, the food wet component is still under development, but the hydrodynamic and biochemical parts are fully operational. For the Iberian Seas and the North and East Atlantic area, that is the latest implementation, and is still under development. Now I would like to move to the final part of this presentation by showing you some concrete examples on the application of the EU Marine Modeling Framework for policy needs. But before going into the details, I want just to stress that in each one of these cases, there is at least one or two scientific peer review publication backing up this result. I will not go into the details of the publication because I would like to concentrate more on the political, or not the political, but on the policy side of this work. So I will start with an example regarding the water abstraction. So changes in the water flow into the marine environment. This flow will change, or it's changing, by different forcing factors, such as climate change, so changing in the evaporation precipitation balance, but also because of the human use. We just recently learned that Ethiopia has just built this huge dam in the Nile, and they are starting to fill it up. So that will obviously change the flow of fresh water that the Nile is really. At the European context, there are many policies which are concerned with the water flow, or the fresh water flow into marine systems, so which are, for example, to name just a few, the Water Framework Directive or the Marine Strategy Framework Directive, but also the Drinking Water or the Bathing Water Directive are concerned with this aspect. So in this particular application, GRC wanted to test what will be the impact on the Mediterranean marine ecosystem provoked by an alteration of the river freshwater flow associated with climate change. So what they did is to calculate for each one of the river districts around the Mediterranean Sea, the percentage of change of the evaporation precipitation, and then apply this to the freshwater flow. They did a run with constant river into the future till the end of this century, and then another run by modifying the freshwater flow by these percentages that you can see in the screen. What they found is that the hydrological modifications are quite limited in the space. So this the first map is the sea surface salinity anomalies. So the with and without the changes in the freshwater. The changes are small and localized nearby the bigger rivers. However, biochemical impacts are much more widespread. So the second map is the chlorophyll A anomalies. And you can see that there are colors throughout the entire Mediterranean Sea. This is due to an alteration of the vertical stability of the water column, and hence on the strength of the mixing, the vertical mixing, and the amount of nutrients that were injected into the euphotic layer. But for a manager, the message is that wherever you do locally, so if you dam a river or you take more water from your river to, for example, agriculture practice, you are going to impact the marine ecosystem, not just on the river mouth, but it can be a very far-reaching impact. This is very important, for example, with in the sense of the connection of the Water Framework Directive and the Marine Strategy Framework Directive, because they are basically operating on a continuum from the first water to the marine ecosystem. The second application is also related with with the rivers, but in this case, instead of looking at changes in the flow or the amount of fresh water, is looking at changes in the quality of this fresh water. So changes in the amount of nutrients that are injected by the rivers into the marine ecosystem. This alloctonous nutrients input from the river waters is one of the major sources of pollution and the major cause of eutrophication in coastal areas. In this case, the number of directive or legislation, European legislation implicated is very wide. So again, we found the Water Framework Directive, the Marine Initiative Framework Directive, but also of concern is the Urban Wastewater Treatment Plant Directive, the Common Agriculture Policy, Nitrates Directive, etc., etc. So what they wanted to do with this application is to really quantify which is the impact of the riverine nutrients on the marine ecosystem in the Mediterranean Sea. To do that, they concentrated their attention in these three regions and in the Northern Mediterranean Sea, which are the Northwest Mediterranean, the Adriatic, and the Aegean Sea, in which you find typically high chlorophyll level. This is satellite image climatology. So you find here relatively high chlorophyll levels with large river inputs. So what they did with the MMF was to do a very long run from covering from 1960 to 2013 using observe or estimate nutrients in the river. And then they got this climatological chlorophyll image. And then they repeated the same run, but eliminating all the nutrients from the river. This is something that it is very easily to be done in the digital world of a model. It will be impossible to do in a real life experiment. And then they compare these two maps. So what they found is that the impact of the nutrients is very different in the different regions. So it's very important for the Adriatic, it's really important for the Aegean, but it's not that much important for the Northwest Mediterranean Sea. So the production that you can find here is basically supported by oceanographic processes, so mixing within the marine ecosystem. They also found, for example, that the specific nutrient responsible for the production in the different regions is different. So for the Adriatic, the reduction in chlorophyll is due to a reduction in phosphate, while for the Aegean Sea is the reduction in nitrogen, the one that is very important. This has implication, for example, for managing effort. So if you want to reduce a potential eutrophication problem in the Adriatic, you should aim for a measure who reduce phosphate, while for the Aegean Sea, it is best to put the money and the effort in reducing the nitrogen, for example. This is an experiment that was also repeated for the rest of the European basins, also incorporating not only this marine modeling framework, but also other models coming from different institutions around Europe. And they found very similar conclusions in the Black Sea, in the North Sea, and in the Baltic Sea. It's very important not only to reduce the nutrients, but to maintain the ratio between nitrogen and phosphate in a correct level, which is an information that is probably very useful for anybody who is thinking of managing this type of pollution in their rivers. Then we will move to one of the hot topics on marine pollution nowadays, which is the presence of floating litter and particularly plastics in our seas and oceans. We are all sadly familiar with this type of images. We know that floating litter and in particular plastic is a global issue, and it has ecological, economical, and health implications. So we need to do something to try to reduce this very pervasive form of pollution. And the JRC wanted to see if the modeling framework can provide input to all these policies which are related to fighting against litter pollution. So what they did is to test if the MMF was able to simulate the dispersion and accumulation pattern of floating litter. And they used the Mediterranean Sea as a test case. They did so by two different types of approach. On the first one, they started with an homogeneous distribution of litter in the Mediterranean Sea, and then they run the model and they see where the litter was accumulated. They did this type of analysis, and then they find out that the accumulation zones are very dependent on the season. So they change from summer to winter. And that's, for example, a very useful information if you want to go out to the sea and clean up and remove plastic. The model can inform you where is the best season and the best area to go and to try to clean up the litter from the sea. But also, they use this simulation to assess where this floating litter that was homogeneously distributed in the Mediterranean Sea will most likely end up in the beach. So you can see where the accumulation of litter at the beach can occur. So that was the first test case. So that was a demonstration because that compared quite well with the survey data. So the MMF and the Lagrangian tool that they have incorporated there could be used to track the dispersion of floating litter. And actually, this is an approach that has been already applied and published for the Black Sea, and is now under development and being tested for the North Sea and the Baltic Sea. Also, in this field of the litter pollution, they wanted to test a different aspect. So what they wanted to see is how much of the litter that you can find in a particular country coastline is generated in that particular country and how much is coming from abroad. This is a question that was asked by member states because they very recently signed an agreement to reduce the presence of litter on the beach to a maximum of 20 items per 100 meters of coast. Some member states were very rightfully concerned about the transboundary litter. So litter that were arriving to their coast, but it was not generated by them, but it was coming from somewhere else. Because in that case, if you have a lot of your litter coming from abroad, there is the range of options that you have to fight against this pollution are much more limited. You cannot reduce the litter in the origin. So what they did with the MMF was to start a simulation in the fashion that is shown in the map. So releasing litter in the coastal areas and assigning this litter to each one of the countries, which are the colors in this case. And in this particular simulation, what they did was to integrate the model backwards in time. Instead of moving the time forward, they move it backward. And then they got this type of result. These are the origin of the particles which end up in Italy. So that will be this yellow area in the left map. So there is a lot of particles which are generated in Italy, within Italy, which is quite normal and expected. But also there is a lot of litter which is coming to Italy, being originated in France, in Spain, in Morocco, Algeria, etc. So they repeated this experiment for all the European countries for 11 years of hydrodynamic data, and they come to the conclusion that almost 30% of the coastal litter in the Mediterranean Sea is transboundary litter. So it's originated in another country to the one that is found in the coast. So that's a very important message, because it is clearly demonstrating that there is no boundaries in the sea. So whatever you put in the marine environment will move freely. There is no barrier to the distribution, and we need then to work together in order to reduce the pollution of plastic. That's particularly true in this basin, in which we found European countries, we found Middle East countries, and North African countries with very different socioeconomic realities. So we need to bring everybody on board if we really want to reduce the plastic pollution for this particular basin. Now we keep on dealing with the connection between the rivers and the sea. But in this case, we move from the plastic pollution to chemical pollution. Chemical compounds dissolved in fresh water will enter the ocean, and then they can disperse or accumulate in the marine environment. Water Framework Directive and Marine Strategy Framework Directive has clear limit on the concentration of many substances that can be dangerous for the life and for the marine environment. So JRC wanted to see if the MMF could be used to simulate the dispersion and accumulation of dissolved substances in the marine ecosystem. They did this type of simulation. So this is the dispersion of dissolved substance that is introduced in the sea with the fresh water. So in principle, the MMF could be used for this aim. Then the problem, of course, is that each chemical substance has a different behavior in the water. So you will probably need to build a particular or a specific model for each one of the substances of concern. But also a very nice thing that you can do with this approach is that you can backtrack, or you can flag the origin of each one of these particles, so of these substances, so you can see which river is contributed to the pollution in which area. So you can separate the origin and the accumulation of the pollution, which is also a very important message to be given to managers in order to prioritize the efforts. Now we move from the Mediterranean Sea and we go to the North Sea with a very concrete, and I think it's a very nice example on how this type of digital twins can be used to inform a policy option or a management option. So in this case, it was used to assess how the SOx emission from the shipping industry could impact the carbonate system in the North Sea. So I would like to give you a bit of background information. The shipping industry, the big cargo ships, typically use very low quality fuel because it's much cheaper than the gasoline that we are using in our cars. But they release a very high number of different substances, among which are the SOx compounds. These SOx compounds, when they are released into the atmosphere, can combine with the water, resulting in acid rain. That's why in certain areas in which the acid rain is a problem, such as the Baltic Sea or the North Sea, there was a mandate by the Commission to reduce the amount of SOx that was produced by the shipping industry. The idea of the legislator was that for the ships operating in that region, that they will shift to higher quality fuel. However, that of course will increase much more the cost of the shipping. So the industry came up with a different solution, that was to use scrubbers. So a scrubber is a system which just bubble the exhaust gases through the water and then clean up from some compounds these gases, and then they release it into the atmosphere. Of course, it cleans up the atmosphere, but it introduces in the sea all these compounds that are transferred from the gas to the water. So the question that was posed to JRC is that if they can quantify the impact of this transfer of SOx from the atmosphere to the water on the acidification of seawater. So what they did is just, okay, so let's do a simulation for the North Sea with a biochemical model who has a carbonate system component, and then they were testing how much the pH will decrease if all the SOx emission in the air will be introducing along the shipping routes in the North Sea. I don't think that you can see the scale, but the numbers are really small. It's like the red zone is like 0.0025, which doesn't seem like very much. But if you put that into comparison with the acidification expected from climate change, you can see here in these coastal areas that it's almost double. So the acidification caused by injecting this SOS component into the sea is double than what is expected from the climate change and increase in CO2 in the atmosphere. So what it was, the consequence of this study was that the shipping industry was allowed to use scrubbers, open loop scrubbers, so the one that are just releasing this water into the sea when they are far away from the coast, and particularly far away from rivers. But when they are close to the river, close to bigger ports, they have to use the closed cycle scrubber. So they have to keep this water on board and only release it either at the harbor to a specific facility or when they are far away from the coast. Now we move to climate change and ecosystem. So also, unfortunately, we are living in what is called now the Anthropocene, and climate change is a reality. It's happening, it's affecting all aspects of our life, and it's impacting marine environment. The problem to assess the impact of climate change on the marine environment is that its ramification is very large. So it affects multiple interrelated effects in a non-linear way. So we need models to try to understand which are the impact of climate change on the status and health of our marine ecosystem. For the policymaker, this is really a very important information and necessary information, because all policies are going to take place, all the measures that you are going to implement are going to take place on the background of the climate change, because climate change is happening and we are not reversing it. So the objective of, in this case, was to link the MMF with climate prediction models, so IPCC type of models, in order to see if they can provide this background trend, on top of which you can then test the different policy or management options. So it has been done a few years ago with the CMPI5 models. Now they are working with the new CMPI6 models. And I will just briefly mention one result for the Mediterranean Sea. I think it's a bit representative of what is the potentiality of this work. So these are water temperature, sea surface temperature in the Mediterranean Sea for the different scenarios. So they tested different global circulation model, different RCP scenarios. In all of them, the Mediterranean temperature is going to increase, which is not big surprise. But then they were also testing or looking at the changes in the biochemistry. So this is net primary production in the different scenarios, which doesn't change that much, neither in time or between the different models of the different RCP scenarios. The reason of this, let's say, relative flat evolution is that the trends are different in the two in different regions in the Mediterranean Sea. So the models are predicting a decrease of productivity in the west, while they are predicting an increase of productivity in the east. Everything is related again with the changes in the vertical stratification of the water column. In the west, warming is the dominant effect over salinification. So vertical stratification is increasing, while in the east, salinification is the dominant mechanism. So that is decreasing the vertical stratification and facilitating the mixing in the water column. The good thing about this is that the MMF is linked, so it's ready to be linked to climate model, and it has been used and is being used for creating this baseline or background trend for the different European seas. Finally, and related with this one, it's an example about fisheries, how this MMF can produce information that is relevant for the managing of fisheries. So fisheries are also going to be changing and affected by climate change, by pollution, by the presence of litter, etc., etc. But it's also very much controlled or affected by our actions, so by the fisheries. The major policy that is related with this human activity is the common fisheries policy, which is a very important piece of legislation controlling the way that the European countries should be fishing. But also, commercial species is one of the descriptors of the MSFD, and is the fishing activity is one of the major economic engines of the blue growth. So that's a very important issue for many stakeholders throughout Europe. And what they try to do is that to use the MMF to assess the impact of different fishery management options on the context of the changing climate. So again, we will have a probably evolution of a fish stock because of changes in environmental conditions. So how can we better adapt the fishery sector to these changes? So what they did is just to test different scenarios, different fisheries scenarios over these changes in biomass only due to climate change. So testing the business as usual. So we continue to fish as we are being fishing the last few years. Then there is the common fisheries scenario. So the catch at the maximum sustainable yield, which is this concept of the maximum rate that you can take fish out of the sea. And then some other options that are also contemplated in the legislation. I will not go much into the detail, just giving you an example, which is about the European hake, a very important fisheries in the Mediterranean Sea, and only looking at the RCP 4.5. So link to, and this is for the common fisheries policy scenario. So link again with the changes in productivity that we saw in the biochemical prediction before. The models are predicting an increase of hake in the east, while in the west there is a decrease or let's say leveling up of the fish catches. That's information important, for example, for fisheries, because fisheries are not moving that much, so the fleets are operating in a restricted area. So if models are predicting that that particular resources is going to decline in the future, it is very useful information for a manager in order to adapt to this likely change in the next decades. So wrapping up this this presentation, I hope that I was able to convince you that the EU policies are relying very much in science from the moment that they are implemented to the evaluation and modification. Science and knowledge is a basic part of this process. For doing that, that is done by the European Commission in particular. They use both knowledge that is generated in-house and knowledge that is generated outside, so generated by you, by me, by our peers. So I think that is quite nice to see that our research does matter. So it's not just that we are doing that because we love it and then that will be read by a bunch of colleagues throughout the world, but it is an information that at the end of the day or after a while will contribute to make our life and the life of our society better, and also at the same time that taking care of our resources and our ecosystems. And in this sense, I would like to finish the presentation by mentioning that JRC has just signed a collaboration agreement with JRC for the specific purpose of cooperation in the field of marine research. So this is a collaboration agreement that will last for at least 5 years. It's open to any CSIC researcher. And the idea is to increase the collaboration between the two institutions in aspects that are of common interest. So if you are interested in learning more, or you want to make your research more available for JRC, you want to work with them in any aspect, please contact me. I can pass you the text of the collaboration agreement, and probably I can also help you to put you in contact with some expert at JRC. So please go ahead and make use of this tool that I think is a very nice opportunity for all of us. And with that, I'm finished. I hope that you didn't find this very, very much boring. Thank you.
Bueno, pues muchas gracias, Diego, por la presentación tan brillante que nos has hecho de esta conexión entre la ciencia y la política, que nos dedicamos principalmente a ciencia, que veamos que todo el conocimiento que se está generando al final se traduzca en esta política de la Comisión Europea. También te quería agradecer como uno de los potenciales usuarios de ese agreement, sobre todo porque tú fuiste los que empujaste a que saliera ese acuerdo entre el GRC y el CSIC, en concreto, vamos, el INMAN, pero todo el Consejo. Entonces, de aquí a todos los que nos están viendo, compañeros del CSIC, aprovechemos ese esfuerzo que pusisteis para generar este convenio y que se pueda aprovechar un sitio muy bueno de investigación que nos permite a los científicos no perder la visión de utilidad que tiene la ciencia para generar este tipo de modelado, que al final pues que se traduzca en políticas que ayuden a una mejor gestión del ecosistema, de mitigación del cambio climático, todos los ejemplos que nos has puesto, y de verdad pues agradecerte todo ese esfuerzo, ¿vale? Ahora pasaremos al turno de preguntas. El chat, como veis, está abierto. Y nada, iré escribiendo ahí las preguntas y se las iré trasladando a Diego, ¿vale? Por ahora, mientras que el resto de usuarios que han estado atendiendo van escribiendo, yo tenía algunas preguntas, y es cuando hablabas de sobre todo el tema de modelado, si hay conexión con porque por lo que entiendo la mayoría de los modelos son propios que habéis estado trabajando vosotros, pero luego hay toda una herramienta o un programa como es Marin Copernicus de CEME. Entonces no sé si existe conexión entre los modelos LMMF que hacéis vosotros con CEME, si utilizáis parte de ese, porque al final hay una inversión y una cantidad de esfuerzo puesto también. Entonces si nos puedes decir algo sobre eso, cómo hay esa conexión, pues te lo agradecería.
Sí, gracias, Gaby. Verá, es una pregunta muy relevante porque, como dices, Copernicus es uno de los programas marinos más grandes en términos de financiación que hace la Comisión, tanto de observación como de remote sensing como de modeling. La conexión entre el MMF y la parte de modeling de Copernicus no es tan fuerte como debería ser, porque la aproximación es un poco distinta. En Copernicus se han centrado en tener modelos operacionales que sean capaces de describir el estado actual del ecosistema usando técnicas como asimilación de datos y ese tipo de integraciones que permiten tener una descripción muy buena del estado actual del ecosistema, pero tiene la desventaja de que no permiten hacer proyecciones, no permiten hacer escenarios porque una parte muy importante de su información viene de los datos. De hecho, ahora mismo sé que hay conversaciones bastante fuertes entre Copernicus y el JRC, porque Copernicus quiere potenciar esa parte de modelos predictivos. De tal forma que la idea es que se use la experiencia que el JRC ya ha tenido con este MMF para ayudar o, digamos, colaborar con Copernicus y desarrollar esa parte de modelos predictivos dentro del CEMES.
Perfecto, y viendo otra. Vale, otra pregunta, porque casi todos los ejemplos que ponías eran del Mediterráneo, la mayoría, exceptuando aquel que hablaba de contaminación atmosférica y barcos. ¿Hay algo concreto porque está muy enfocado al Mediterráneo, porque es una zona de interés prioritaria a Europa, o cuál es la razón?
Vale, sí, también. A ver, hay dos razones. Bueno, la razón principal es que cuando yo empecé a trabajar en el JRC fue en 2013, se priorizó el trabajo en el Mediterráneo porque era la cuenca, junto con el Mar Negro, donde había menos información de modelos. Tanto el Mar del Norte como el Báltico, había ya muchos grupos a nivel europeo que estaban trabajando, que tenían modelos digitales, modelos que representaban los ecosistemas, mientras el Mediterráneo estaba un poquito más huérfano, digamos. Entonces, cuando se decidió las prioridades, se decidió invertir más en esta cuenca, que era la que necesitaba un poco más de ayuda. Eso ha derivado en que siempre se ha trabajado primero en el Mediterráneo. Con lo cual, todos los modelos, todos los módulos, las aproximaciones se han hecho primero en el Mediterráneo y después se han trasladado a las otras cuencas, porque también, claro, cuando yo empecé en 2013 éramos solamente 3 personas trabajando en este tema. El grupo fue creciendo en el tiempo y se fueron incorporando más cuencas. Y es por eso que el Mediterráneo es, digamos, la cuenca estrella del MMF, simplemente porque se empezó a trabajar antes. Pero todo el tema de hidrodinámica, biogeoquímica y de polución por plástico está ya implementado tanto en el Mar Negro como en el Báltico como en el Mar del Norte.
Vale, aquí viendo el chat, que si alguien se anima a que escriba, ¿vale? Estoy siguiendo por aquí. Y otra preguntita que me surge al hilo de este: ¿existen otros países, otros sitios que estén interesados en este tipo de Marine Framework que habéis creado aquí en la Comisión Europea para poder exportar ese tipo de herramientas a nivel, yo que sé, continental o a nivel de país, ¿no? Que sea exportable? Porque al final es un toolbox, dijéramos, un framework donde este conocimiento lo puedes trasladar cambiando el modelado, pero si la estructura que hay detrás permitiría, pues, desarrollar este tipo de para otros países, sobre todo mejor en vía de desarrollo, que no hay tanta ciencia detrás, ¿no? O que no hay tanto grupo desarrollando ese conocimiento.
Sí, claro, lo ideal sería, por ejemplo, en cuencas que compartimos con otros países, como mencionaba antes, Mediterráneo o el Mar Negro, donde muchos de los países ribereños no tienen la capacidad para generar este tipo de conocimiento, que esta herramienta se ponga a disposición de estos países. Después, aplicarlo a otras regiones lejos de Europa. En principio, el JRC no estaría interesado en eso porque su misión es asesorar políticas europeas. A no ser, por ejemplo, sí que se estuvo hablando durante un tiempo de aplicar este tipo de aproximaciones a la zona ártica, porque no es europeo, pero es una zona donde geopolíticamente interesa tener ese tipo de herramientas para poder informar si en algún momento la Comisión Europea o la Unión Europea tiene que tomar alguna decisión allí. Eso es algo que yo creo que sí que querrían hacerlo, pero de nuevo se encuentran con el problema del personal, que tampoco tienen recursos ilimitados y no se pueden implementar en toda la zona.
Vale. Y bueno, yo creo que si no hay en el chat pregunta, una última, además al hilo de lo último que dice, falta de personal, y si hay jóvenes investigadores viéndonos en el canal online, si existe posibilidad o como para jóvenes investigadores pueden acabar, igual que fuiste tú hace años en el JRC, si nos puedes hablar un poco de la política de contratación, si hay becas, si hay contratos para postdoctorado, predoctorado, algo relacionado con el tema laboral, por si hay alguien que interese.
Vale. Bueno, ahora mismo el tema de personal en la comisión está un poco bajo mínimo porque evidentemente tienen que reducir el número de staff por el Brexit. Han reducido el número de Estados miembros, con lo cual la comisión debería también de menguar. Sí que, por ejemplo, a nivel de JRC existe la posibilidad de hacer estancias que son una especie de becas más enfocadas a personas que están haciendo la tesis, por ejemplo. Después, a la hora de ya a nivel postdoc, ahora mismo, como te digo, existen pocas opciones porque las becas que existían antes o los contratos postdoctorales que existían antes ya no existen, y la única forma de incorporarse sería a través de un contrato de contrato a ley. Pero si hay alguien que está interesado, que le apetecería tener algún futuro posible en este ámbito de la interfaz entre la ciencia y la política, yo le recomendaría que se metiese en la página del JRC, que mirase las opciones de trabajo y que se inscribiese. Es una especie de bolsa de trabajo como la que tiene el CSIC. Bueno, tú presentas tu currículum, tú tienes que definir muy bien tus palabras claves, porque es esta base de datos la que se usa para reclutar a gente como contrato a ley o como cualquier otro tipo de contrato. No cuesta nada, es una aplicación online que puedes subir y nunca se sabe qué oportunidades pueden surgir de allí. De todas formas, si alguien realmente quiere hacer una estancia allí porque le interesa mucho hacerlo y está trabajando, está haciendo la tesis en el CSIC, el acuerdo de colaboración contempla el intercambio de personal. Posiblemente no haya posibilidad de financiar, porque este es un acuerdo de colaboración que no tiene dinero, pero a través de esa herramienta a lo mejor se puede acceder a algunos fondos de las bolsas de trabajo que tiene el JRC, al menos para financiar la estancia allí. Si alguien está muy interesado en algún aspecto, que también se ponga en contacto conmigo y podemos discutirlo.
Vale, muchas gracias. Y una pregunta que nos escribe Diego Álvarez del Instituto Español de Oceanografía, y nos indica que a pesar de que los modelos dan mucha información, también pueden tener mucha incertidumbre, eso por un lado. Y en segundo lugar, pregunta cómo se gestiona esta incertidumbre en el proceso de asesoramiento por parte del JRC y de gestión de la comisión.
Sí, muy buena pregunta. Y es obvio que los modelos son aproximaciones y que el nivel de incertidumbre es alto. La forma que normalmente se está tratando este tema es mediante el ensemble, bien porque se usen varios modelos, distintos modelos de oceánicos o bioquímicos, de tal forma que se puedan evaluar cuáles son las tendencias comunes o dónde los modelos divergen, o si los cambios son consistentes o no. O si no tenemos disponibles varios modelos, lo que sí se intenta es, por ejemplo, para hacer predicciones de cambio climático, es usar distintos modelos de circulación atmosférico y distintos escenarios de emisiones, de tal forma que, de nuevo, a lo mejor no se puede decir que el cambio va a ser de 0,5 unidades, pero sí que la tendencia general es a incrementar o a disminuir, para buscar patrones comunes que sean consistentes.
Gracias. Tenemos otra pregunta de Marta Álvarez sobre cómo encantaría ver cómo se definen e implementan los mecanismos de mitigación de la captura de CO2, acidificación, y cómo se ayuda a definir una estrategia de la Unión Europea, incluso por países zona, apoyada por modelos y observaciones.
Sí, es un tema muy interesante. Gracias, Marta. Como sabéis, el tema de la captura de CO2 por parte de los ecosistemas marinos es uno de los aspectos clave que se están explorando ahora, tanto a nivel de Estados miembros como a nivel europeo, por muchas razones, motivos por ejemplo, de protección de ecosistemas que pueden actuar como sumideros, pero también porque la cantidad de CO2 que un ecosistema natural de un Estado miembro, de un país en particular, pueda absorber, puede influir, por ejemplo, en las cuotas de emisión de carbono. Si tenemos un país en el cual se absorbe muchísimo carbono en su zona económica exclusiva, por ejemplo, esa cantidad puede ser incorporada dentro de los Carbon Trade Emission, y obviamente tiene implicaciones muy importantes económicamente, con lo cual no solamente es un aspecto ecológico, más es un aspecto político y económico. El problema con el CO2 es que son tantos los ecosistemas que intervienen en su dinámica, que no hay un modelo que pueda contemplar todos ellos, con lo cual lo que se está intentando es aplicar modelos parciales a los distintos compartimentos ambientales, por ejemplo, al componente pelágico, a las fanerógamas, a las zonas costeras donde tienes vegetación, e intentar agrupar esta información de tal forma que se pueda tener ¿cómo se dice? Un stock o una evaluación del stock de carbono que pueda intercambiarse por este tipo de modelos. En este caso, por ejemplo, los modelos llegan hasta cierto punto y a partir de ahí tenemos que basarnos totalmente en las observaciones, ¿vale? En los sistemas de observaciones de monitorización a largo plazo, por ejemplo, lo que tiene el IEO en las radiales, o el trabajo que se hace aquí en el estrecho con la serie de observaciones de CO2, esa es la información que necesitamos para constreñir los modelos y reducir la incertidumbre, como se mencionó anteriormente.
Vale, pues sí, que aquí en el chat no hay ninguna pregunta más, ya hemos pasado la hora que teníamos más o menos prevista y nada, de nuevo agradecerte, Diego, la impresionante charla del trabajo que desarrollaste en el JRC y que sigue desarrollando. De nuevo agradecer la fuerza y el empuje que diste para ese acuerdo, que seguro que utilizamos utilizamos muchos investigadores y nada, pues la presentación ha quedado grabada, que queda en el canal de YouTube de Dickman CSIC y nada, también agradecer al organizador del simposium por todas estas charlas tan brillantes que nos están brindando. Así es que, pues, muchas gracias de nuevo y a todos los asistentes.
Muy bien, Gaby, muchas gracias a ti y por supuesto a todos los que habéis aguantado conmigo esta hora de charla. Y nada, de nuevo ponerme a vuestra disposición si queréis saber algo más del trabajo, del convenio, lo que os pueda ayudar, que tenéis mi correo, me podéis contactar cuando queráis. Muchas gracias.